Today we're doing notes, 4.1 math analysis on radian and degree measure. So in our table of contents, this is going to be chapter 4, and I'm going to call it MA because this is from our math analysis book, trigonometry. And the first section we're going to do is 4.1, which is radian and degree measure. Today we are doing the first part of this, which is going to be on the degree measure. Next class, we will be dealing with the radian. So I'm going to put my title here, 4.1 MA, radian and degree measure. Now, the first part of these notes are actually on a worksheet, a handout that I normally would have given you guys. We would have pasted in. So you guys can refer to it if you want to print it and paste it in. Feel free. I'm just going to flip to that screen right now so we can discuss that, and then we'll try some examples. So here are the notes that I gave you guys. Okay, 2 pages of in a foldable. Let's focus in on this right here, the front page. And what we're dealing with is a unit circle. Okay, and this is a circle centered at 0, 0 on a graph with a radius of 1. Okay, and when you go all the way around the circle, it is 360 degrees. And these are the important ones that we need to know. Obviously in between there's an infinite amount of ones, but these are the ones that are going to be important to us when we're doing our trig. So 0, 30, 45, 60, 90, that's quadrant 1. Okay. Quadrant 2, 120, 135, 150, 180. Quadrant 3, 210, 225, 240, 270. Quadrant 4, 300, 315, 330, 360. Okay, that's all the way around the circle. Now, something to notice, and I'm going to be doing this in different colors. So let me just get a color here. So when we're talking about a unit circle, all of these degrees here, everything here can be related to quadrant 1. So quadrant 1, this is 30 degrees, and it's 30 degrees above your x-axis. Over here, this 150 is also 30 degrees above the x-axis. Okay. So 150 is going to have 30 degrees as what we call the reference angle. Everything here in quadrant 1 will be our reference angle. Down here in quadrant 3, 210 is 30 degrees below. Over here, 330 is 30 degrees below. Now, so all of these would have 30 degrees as their reference angle. They're all 30 degrees above or below the x-axis. Now here's our 45, okay? So 45 degrees. Over here on this side, 135 would be 45 degrees above on this side. 225 is going to be 45 below. Over here, 315 is going to be 45 below the x-axis. So all of these angles are going to have 45 degrees as its reference angle. Let me get another color. So we've got our 60 degrees here. Whoops, let me undo that. Get a different color. So my 60 degrees is, again, 60 degrees above the x-axis. Over here on this side, 120 is 60 degrees above the x-axis. Down here, 240 is going to be 60 degrees below the x-axis, and 300 is going to be 60 degrees below the x-axis. So all these ones in green are going to have 60 degrees as the reference angle. Okay, and just a little, so we can see this. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay. Now, the next idea we're going to be talking about here is dealing with standard position. Okay, standard position. Standard position of an angle. An angle in standard position is in standard position if its vertex is located at the origin and one ray is on the positive x-axis. That's always where the starting of it is. The ray on the x-axis is called the initial side, and the other ray is called the terminal side. If the terminal side of an angle lies on the x-axis, or on the axes, okay, x or y, such as 0 degrees, 90 degrees, 180 degrees, 270, and 360, it is called a quadrantal angle. The angle shown at the right is referred to as a quadrant 2 angle, since its terminal side lies in quadrant 2. So let me just put this up here. So you see, this is the initial side. It's starting on the positive x-axis. That's where we start in standard position. And then we draw the other ending side, which we call the terminal side, and we show the direction. You see that it's going this direction, okay? Because we can also have angles that go the other direction. So I can have it go this direction. Okay, this would be a positive angle. This would be a negative angle. Both of them start in the same position and end in the same position. This one is covering less distance than this one. So again, this one would be a positive angle. This one is going to be a negative angle, and that's in standard position. Now, the angle, like I was saying, is measured by the amount of rotation from the initial side to the terminal side. If measured in a counterclockwise direction, the measurement is positive. If measured in a clockwise direction, the measure is negative. A negative associated with an angle's measure refers to the direction of the measurement, clockwise. Okay? So, like that example, now they gave us some values here, okay? So if two angles in standard position have the same terminal side, they are called coterminal angles. So this is 120 degrees positive, and this one here would be a negative 240 degrees because all the way around is 360. So if this is 120, then what's left over is 240, but I'm not going 240 in the positive direction, which would put me down in this quadrant, quadrant 3. I'm going 240 this direction, okay, and it's going to put me in quadrant 2. So in the diagram at the down here, you have a positive 120 degrees, and you have a negative 240 degrees, and those are called coterminal angles. Now, I had talked about a reference angle a second ago, and a reference angle is the angle that's always positive, and it's always less than 90 degrees. So it's always going to be in quadrant 1, okay? So if I go back to this picture here, okay, when we're talking about reference angles, our reference angles will be in this quadrant right here, okay? In between 0 degrees and 90 degrees. So again, 30 would be a reference angle for 150, for 210, for 330. Every single angle that is 30 degrees above or below the x-axis. Similar with the 45, degrees. It would be a reference for all three of these, along with any other angle that is 45 degrees above or below. And then 60. And that's true of any angles in between here. But again, these are kind of our important ones. So again, if I flip over to the page I was just on before, when we're talking about reference angle here, the reference angle is measured from the terminal side of the angle to the x-axis, never to the y-axis. So this here is in quadrant 1. This is 60 degrees. This is a reference angle. Over here in quadrant 2, okay, if I went 120 degrees, how far above the x-axis am I? 60. So again, 60 degrees would be its reference angle. Similar idea if I'm looking at these, okay? So again, if I went 240 degrees, I am still 60 degrees above below the x-axis, because this is 180 and 180 take off from 240 is going to be 60. So you're always concerned how far above and how far below the x-axis you are. So 240 degrees would have 60 as its reference. Over here, if I'm in quadrant 4 and I went 315 degrees, 360 minus 315 leaves me with 45. This is 45 degrees. So my reference angle is 45 degrees. Okay, always from quadrant 1. Always how far below the x-axis the angle is, or how far above, how far above it is. Now, we can have angles that are also more than 360, okay, greater than 360, meaning that they go around the circle more than one time. So if the starting angle is greater than 360, start by subtracting 360 from the starting angle as many times as needed to arrive at a new starting angle that's within 0 to 360, okay? Then from there, you're going to figure out its reference angle. So, for example, 970 degrees, okay? So obviously I'm going around more than one time, okay? So if I wanted to find the reference angle for 970, I would subtract 360, I get 610, still not in between 0 and 360. I then would subtract 360 again and I get 250, okay? And 250 degrees is in quadrant 3. So over here, let's say that this is 250 degrees, okay, that I went 250 degrees, okay, this direction, 250 degrees, this direction. Then how far off is 250 from this 180? So I'm going to take 250 minus 180 and see that I was 70 off. So this right here, let me just get a different color. So this right here, just make sure it's thin. This right here, this angle right here, that part right there is going to be this 70 degrees. It is 70 degrees below the x-axis. And so the reference angle for 970 is 70 degrees. Because we're trying to figure out how far it is above or below the x-axis, okay? So you see that I went around the circle once, I went around the circle twice, and then I went around the circle another 250 degrees, okay? Another bit of information we need is how far is dealing with, complementary and supplementary angles. So complementary angles add to 90 degrees. Supplementary angles add to 180 degrees, okay? We're going to have some questions about that. And on the last page of this, and then we're going to try some examples, okay? Angles are measured in degrees. That's all we've been dealing with, but they can also be broken down smaller. Degree, minutes, seconds, okay? And so here we're talking about changing from degree, minutes, seconds to decimal degree form, okay? So some conversions you need to know for degree, minutes, seconds. 1 degree is 60 minutes, okay? That little mark there, that single tick mark means minutes. So 1 degree equals 60 minutes. 1 minute equals 60 seconds. So when you have the two little marks here, that's going to be 60 seconds. So again, 1 minute is equal to 60 seconds. And 1 degree is equal to 3,600 seconds because there's 60 seconds in a minute and 60 minutes in a degree, and 60 times 60 is 3,600. So again, 1 degree is equal to 3,600 seconds. So let's say we were trying to convert 126 degrees, okay, 126 degrees, 12 minutes, 27 seconds into decimal degree form. So we know it's going to be 126 point something, okay? So here I wrote my 126 plus my 12 minutes plus my 27 seconds. Now, this 12 minutes, we want to know, it's not a full degree because 60 minutes makes up a degree. So what part is it? So I'm going to take 12 over 12 minutes times 1 degree over 60 minutes, or 12 minutes over 60 minutes, and that's going to give me a fraction. So when I put 12 over 60 in my calculator, I get 0.2. So it's 0.2 degrees. That's what this piece is. Now my 27 seconds, again, I'm trying to convert this to degrees, and there are 3,600 seconds in 1 degree. Okay, so 1 degree is the same as 3,600 seconds. So I multiply these together and I get 0.0075. So if I was doing this on a calculator, okay, this is how I would normally do it. So if I was doing that same problem, okay, I'm going to take, again, it was 126 plus and 12. And this is how I usually do it. I usually do 12 divided by 60. Okay, so this is 12 minutes divided by 60 minutes to see what part of a degree I have, because 60 minutes is 1 degree, plus 27. 27 divided by 3,600. And I end up with 1.26, 0.2075. Okay, and again, if I bring this over here, you can see I get the same answer. So I am adding the 0.2 part on and the 0.0075, and when I add that all together, I get this. And this is my answer in decimal degree. This one up here is my answer in degree, minutes, seconds. So let's say we're going the other direction, okay? So if you are going the other direction and you are trying to start with 24.263 degrees, and we want to change it to degrees, minutes, seconds. So I'm going to break this up. Okay, I know the 24, the part in front of the decimal is going to be 24 degrees. I'm concerned with the 0.263. Okay, so this is what part of a degree I have. So what I'm going to do is, again, this is kind of like the big ones that we deal with in integrated one. So I want to cancel out degrees, okay? So I want to change it to minutes. So when I'm talking about 1 degree and 60 minutes, this is really a big one. They are the same. But my concern is I want my degrees to cancel out, so I need my degrees below. So I'm really going to be taking this and timesing it by 60 minutes. Okay, when I do that, I get this many minutes. So now I know that I have 15 minutes and the other part is going to be my seconds. So then that's my 15 minutes. Now I'm going to focus on this 0.078. And so this 0.078 is what I'm now going to be focusing on changing. And I'm going to be changing this, which is in minutes, into seconds. So I'm going to take 0.78 minutes. And how do minutes and seconds relate? 1 minute is the same as 60 seconds. Okay, so this, which isn't quite a full minute, okay, is going to be multiplied by 60 seconds to change it into seconds. So when I do that, I end up with 46.8 seconds. And then my final answer is 24 degrees, 15 minutes, 46.8 seconds. So now we're going to go to our composition book and we're going to do some examples. Okay, so first example, determine the quadrant that the angle's in. Okay, so let's say we have 130 degrees. So I'm going to kind of sketch this out. Now we know that this is going to be 0 degrees. This is 90 degrees. This is 180 degrees. So it's going to be somewhere in between here. So when we're drawing out an angle, we always start on the positive x-axis. Okay, that would be my initial angle. And my terminal angle is going to end up being somewhere in here. Okay, so in between 90 and 180. So let's just say here. And let's get a different color. This would be, for example, 130 degrees, starting here and ending here. Now, what quadrant am I in? I am in quadrant 2. So my answer here would be quadrant 2. Okay. Let's say we had another one. And let's say that this one was a negative 260 degrees. Okay. So I'm going to be going the other direction. Okay, let me just put my 0, my 90, my 180, my 270, and then back to 360 over here. So in this case, I am again going to start here. Okay, now I'm going to be going this direction this time. So if as I'm going around this, I've gone 90, I went another 90, which makes 180. If I go another 90, that puts me at a 270. So it's actually going to be in quadrant 2, and it's going to be pretty close to my, my 90 degree here. So let me just draw it kind of like this. And again, I started here. I went 90, negative 90, another negative 90, which is 180. Almost another negative 90, which would have put me at 270 up here. Okay, and so this would be negative 260 degrees. And I actually ended up at quadrant 2. Okay, and so this answer is quadrant 2. So now let's go through another type of problem that you guys are going to be seeing. Okay, so for this example, what we're going to do is we're going to determine two coterminal angles. And what they're going to want is one positive and one negative. Okay. So in this picture, draw a picture. So They might give it to you in a picture. I'll do one that's in a picture. I'll do one that's not in a picture. So let's say in the picture, they give us this. And let me just write my 0, 90, 180, 270, and then again, this would be back to 360, okay? And let's say we're starting here. And let's say this is our picture, and that they tell us that this is 135 degrees. And they want two coterminal angles, which basically means we want angles that start in the same position and end in the same position, okay? So to get, let me start with the negative one. That might be the easier one here to do. So if I'm doing the negative one, that means I'm going this direction. I'm starting here and I'm ending here. So I'm starting here, just start right here, and I'm ending here. So what I'm basically going to be doing is for this one in blue, I want the rest of this angle. This is 360, okay? And I went 135 of that. So for my negative one, I'm going to take my 135 and I'm going to subtract 360 from this. And when I take 135 minus 360, I get a negative 225 degrees. So this one here is going to be a negative 225 degrees. That's what that one is. So this is going to be one coterminal angle. Now I need another one, and this time I'm going to do positive. So what I'm going to do is whenever I want coterminal angles, I'm adding and subtracting, okay, adding and subtracting 360 on or off. So I subtracted to get my negative. I'm going to add it to get my positive. So I'm going to take 360 to, I'm sorry, let me start with my angle. Okay, so I'm going to start with my angle. I'm going to start with my 135 here. I subtracted it. Now I'm going to add 360 onto it. And when I add 360 onto it, I get 495 degrees. And that's going to be another coterminal one. So let's say that, get another color. So what's going to happen is for this one, I went my 360, so I went all the way around once, and then I went to here. Okay, so I started here, I went 360, and then I went an extra 135, and that gave me this one here. So that's where that one came from. Okay, so now let's say I gave us one that wasn't drawn in a picture. So let's say it was negative 60 degrees, okay? And I want my positive coterminal and a negative coterminal. So again, I'm going to take my negative 60 degrees, and if I add 360 degrees, that's going to give me 300 degrees. That would be positive. Then I can take my negative 60 degrees, and instead of adding, I can subtract 360 degrees. And when I take a negative 60 minus 360 degrees, I get a negative 420 degrees, and that would be my negative coterminal angle. Now I can continue to add and subtract. So again, if I was doing this and I started off with negative 60 and I was trying to get a positive one, okay, I added my 360. That gave me 300, but I can keep adding 360. That gives me another one. I can keep adding 360. So every time I add 360, I'm going around the circle another time. All of these would be possibilities for a positive coterminal. And if I start with my negative 60 and I subtracted 360, that gave me my negative 420, and I subtracted 360 again. I went around one more time, negative 780. I subtracted 360 again, and so on, and so on, and so on. Okay, so all of these would be coterminal. So to get a coterminal angle, to get a positive one, you're going to add 360 until you get to a positive. Okay, you might add 360 and you might still be negative. You add 360 until you get to a positive, and you subtract 360 until you get to a negative. Now, the next idea that you guys are going to be asked to do is going to be dealing with that complementary and supplementary angles. So let's try an example like that. So let's say they ask us to find, if possible, because sometimes it's not possible, the complement and the supplement of the following. Okay, the complement and the supplement. So let's say we're going to do 18 degrees, okay? And we're going to find the complement and the supplement. So the complement, again, is adding to 90 degrees. So if I want to find the complement, I'm basically asking what can I add with 18 degrees to get to 90 degrees. So I'm going to take 90 degrees minus 18 degrees, and I'm going to end up with 72 degrees. And that's going to be my complement. For the supplement, it's what can add with 18 degrees to get to 180 degrees. So I'm going to take 180 degrees minus 18 degrees, and I'm going to get 162 degrees. Okay, so what adds with this to get 90? What subtracts with this to get 180? I'm sorry, adds with this to get 180. Okay, let's say we try 115 degrees. Okay, now for 115 degrees, the complement is going to be impossible. There's going to be none because I'm already at more than 90 degrees. Okay, so if I'm at more than 90 degrees, I am not going to have a complement. I have to have something less than 90 degrees that I'm trying to add to get to 90 degrees. So no complement. Now my supplement, I'm going to take 180 degrees minus 115 degrees. And I end up with 65 degrees. And that would be my supplement. Okay, and the last examples are going to be trying to convert decimal minutes seconds and decimal degree form. So let's say, for example, we want to convert angle measure to decimal degree form by hand. And we're going to use a calculator to do the math, but we're going to be showing our steps here. That's what I mean by hand. So on the first one, let's say we have 85 degrees, 18 minutes, 30 seconds. And I want to convert that into decimal degree form. So this is how I go about doing it. I know that I'm starting with the 85 degrees, so it's going to be 85 point something, okay? Plus my 18 minutes, there's 18 minutes and 60 minutes makes a degree. So you can see I don't have a full degree. So I'm taking my 18 over 60. Plus I'm going to take my 30 seconds. And how many seconds in a degree? 60 times 60 or 3,600. And I'm going to put this into my calculator and get my answer. Okay, so I'm going to go 85 plus 18 divided by 60 plus 30 divided by 3,600, and I get 85.3083 repeating degrees, and that's my answer. Okay. So let's try another one. So let's say it's a negative 128 degrees plus 17, sorry, I didn't put a plus there yet. 17 minutes and 12 seconds. Now this one you have to be careful. This is negative. You want the negative outside because you should still be getting the same decimal degree measure for this as a positive as you would for this as a negative. So I'm going to put my negative outside of all of this, and I'm going to have 128 plus 17 minutes out of 60 minutes plus 12 seconds out of 3,600 seconds. And again, that negative is going to be outside. The whole thing is going to be negative, but you don't want this to be negative and then write pluses in between. So you want to have that negative outside the whole thing. Okay. So I'm going to have, I'm just going to put it in as a positive, 128 plus 17 out of 60 plus 12 out of 3,600. And I get a negative 128.286 repeating degrees. And that's that answer. Okay. So now let's go the other direction. Okay. So this time we're going to start with it in decimal degree form and convert it to decimal minutes seconds, DMS. Okay, so example. Convert Engle measure to degree, minutes, seconds by hand. And on your homework today, I want you guys to show the steps like this. Obviously, you can then use your calculator, and similar idea when we're doing these ones down here. Okay, so let's say we have 38.427 degrees, okay? So what I'm gonna do is I know it's gonna be 38 degrees. I know that part of it, so I'm gonna have 38 degrees. Plus, I have right now 0.427 degrees. And I wanna change this decimal degree into a minute, okay? So I am going to take 38 degrees plus 0.427 degrees times 60 minutes. So now this is going to convert it to minutes, okay? Because I don't have a whole minute, but however many degrees I have here, I'm going to multiply it by 60 minutes. So when I do that, I'm going to have my 38 degrees. And now I'm going to have, and let's put this in the calculator. So 0.427 times 60, I end up with 25.62. So now I have 25.62 minutes. So now I converted this degrees to minutes. So I know I have 38 degrees. I know I have 25 minutes. And now I need to focus on this. Okay, so I've got 38 degrees, 25 minutes, and I have 0.62 minutes. And these minutes I'm going to change into seconds. And so to change them into seconds, I'm going to have 38 degrees plus 25 minutes plus 0.62 times 3,000. Sorry, this is in minutes. So I'm going to be timesing it by 60 seconds, okay, because there's 60 seconds in a minute. And so I'm going to have 38, so I'm sorry, I'm going to have 0.62 times 60, and I end up with 37.2. So I'm going to get 38 degrees, 25 minutes, and this right here is going to be 37.2 seconds. Now, you can have seconds as a decimal. You cannot have minutes as a decimal, and you cannot have degrees as a decimal if you're putting it in decimal, I'm sorry, in degree, minute, second form. Okay, and then that would be our answer. So let's try one more. So the next example, we have negative 150.2455 degrees. Okay, so I know I'm going to have a negative answer. Okay, let me just go like this. It's going to be a negative 150 degrees plus 0.2455. This is my degrees that I'm going to be changing to minutes. Okay, so I'm going to be taking this and I'm going to be timesing it by 60 minutes. So now I'm going to have 150 degrees. And when I do that math, and I take 0.2455 times 60, I'm going to get 14.73 minutes. Okay. And then I need to take this 0.73, sorry, minutes, one mark. Jumping ahead, minutes, okay? So now I'm going to take my 150 degrees and I have 14 minutes, and I'm going to take my 0.73 minutes and times it by 60 seconds. And so when I do that and I take 0.73 times 60, I end up with 43.8. So I'm going to have negative 150 degrees, 14 minutes, and this was 43.8 seconds. And that's my answer. Now, the last thing I want to show you is that the calculator, the graphing calculator, does have degrees, minutes, seconds on it. Okay, so let me just jot down here. If you look, put this in a little section. So if you look on these calculators, there is on apps angle. To get anything in blue, you need to press second. So if I press second and apps for angle, you see here I get my degree and I get my minutes and I get degree, minute, seconds. Okay, so I would use number 4 if I'm trying to take it from this decimal degree form and change it to degree, minute, seconds. Here, this is giving me the degree symbol. This is giving me the minutes. Now for the seconds is actually here in green on the plus sign. So anytime you want anything in green, you need to press the alpha. Okay, so let me just show you that. So alpha and the plus sign, and when I press alpha and the plus sign, you see you get your seconds. So let me just jot that down. So second and apps, and what you want is angle, And number one is the degree symbol. Number two is the minutes. Okay. And number four is changing it to degree, minute, seconds. And if you want to get the second, you would do alpha because it's in green, and the plus sign. And on the plus sign, you'll see the degree symbol, and that will give you your seconds. Okay. So let me just show that as an example. So use calculator to convert between decimal degree form and degree, minutes, seconds. So going back or forth between. So go through one example of each. Okay, so number one, taking 48 degrees, 28 minutes, 32 seconds, and we're going to convert this. This is decimal minutes, seconds, and we're going to convert it to decimal degree. So on the calculator, this is how you could do it. Again, I personally actually like to do it the way I did it before. Sometimes it's faster for me than trying to get to these buttons, but this is how you do it. So you're going to do 48, and you're going to do the second. So let me get it up here a little more. Let me shrink this down. Okay. Okay, and I'm going to do second, and I'm going to do apps to get angle, and I'm going to hit number one. Okay, and then I'm going to do 28, and then I'm going to hit second and apps, and I want number two. And then I'm going to do 32, and I'm going to do alpha and the plus sign, because a plus sign has that on it. And I end up with 48 degrees, 28 minutes, 32 seconds. And it will give me that answer, okay, which is 48.475 repeating degrees. Now, for me personally, I find doing that sometimes time consuming. So if I was doing this for speed, I would do 48 plus 28 divided by 60 plus 32 divided by 3600. And I get the same answer, okay? Now let's say we're going the other direction, and we had 52.3175 degrees. Now here again, I have decimal degree, and I'm going to be changing it to degree, minutes, seconds. Okay. Now this I actually do find faster. So if I'm doing this, I'm going to be typing in. Okay, so I'm going to type in 52.3175, just like that. And I am going to go to second and apps for angle. Okay, angle. And I'm going to choose number 4. Okay. And it's going to change it for me to 52 degrees, 19 minutes, 3 seconds. So I find that fast. This up here, doing this on the calculator, typing in my minute and my seconds, I personally don't find fast. as long as I know what to divide by. But I did want to show us how to do these on the calculator. Now, when you're doing this on your homework, I do want to see the work like I did in the other examples. And that's our lesson for today. Next time, we're going to learn radians.